Good morning all. We have seen magnetic vector potential. Now let us find the magnetic vector potential of a current loop. Consider a current loop as shown in figure. Let I be the current flowing through it. Now the magnetic field at point P due to an element dl of the current loop is given by Biot-Savart law. The magnetic field at point P be dB, then dB is equal to mu 0 by 4 pi I dl cross r by r cube, where r is the distance from the element to the point P. Now we have the relation del 1 by r equal to minus r by r cube. Let it be equation number 2. Now substitute 2 in 1. That is, instead of r by r cube, substitute minus del 1 by r. Now 2 in 1 gives dB is equal to mu 0 by 4 pi I dl cross minus del of 1 by r. Now take the minus sign outside. dB is equal to minus mu 0 I by 4 pi, then dl cross del 1 by r. We can eliminate the minus sign in the following way. Just write dB is equal to mu 0 I by 4 pi del 1 by r cross dl. Let it be equation number 3. We have our equation number 3. dB is equal to mu 0 I by 4 pi del 1 by r cross dl. Now to simplify the above expression, let us consider another relation. That is, if f is a scalar and a is a vector, then del cross fa. What is del cross fa? Del cross fa can be written as f del cross a minus a cross del f. This can be written as f del cross a plus del f cross a. From that we have del f cross a is equal to del cross fa minus f del cross a. Now in equation number 3 we have a similar expression. Del 1 by r cross dl. Now we can write del 1 by r cross dl as del cross 1 by r dl minus 1 by r del cross dl. Let it be equation number 4. Hence equation 3 becomes, now substitute the value of del 1 by r cross dl in equation number 3, that is 4 and 3 gives dB is equal to mu 0 I by 4 pi del cross 1 by r dl minus 1 by r del cross dl. Let it be equation number 5. Now equation number 5 contains two terms. Let us evaluate the second term. What is actually del cross dl? Del cross dl can be represented as determinant xyz dou by dou x dou by dou y dou by dou z dx dy dz, because dl equal to dx x cap plus dy y cap plus dz z cap, and we obtain the result as 0. That is, the second term in the equation 5 vanish. Hence dB becomes mu 0 I by 4 pi del cross 1 by r dl. This is the magnetic field at point P due to an element dl of a current carrying loop. Now what is the magnetic field? What is the magnetic field at point P due to a closed loop carrying current I. Equation 5 gives the magnetic field of an element dl carrying current I. Now the magnetic field of the entire loop can be obtained by integrating equation 5. That is B is equal to mu 0 I by 4 pi closed integral del cross dl by r. We have taken closed integral because we are considering a closed loop. This implies B is equal to del cross. We can take del outside and write the above equation as B is equal to del cross mu 0 I by 4 pi dl by r. This is the magnetic field, the total magnetic field at point P. We know that B is equal to del cross A. Therefore, since B is equal to del cross A, the quantity inside the bracket, that is mu 0 I by 4 pi closed integral dl by r, should be equal to A. Hence, A is equal to mu 0 I by 4 pi closed integral dl by r. This is the magnetic vector potential of the current carrying loop.